Okay, this is a chapter 6.1 notes. This is a law of sines, how to use trigonometry to solve and find the areas of an oblique triangle. Up to now, we've used trig to solve right triangles. Now we'll solve an oblique triangle. That is a triangle that does not have, I can fit this in there, that does not have a right angle. And there's not enough room for me to write that in there, but there, no right angles. So to do this, we need a couple things. To solve an oblique triangle, you need the measure of one side and then any two other parts. Any two other parts. So that means you need to have like either a side and then like two more sides, or a side and an angle on the side, or a side, and angle, right? You need to have, or side, angle, angle. So you need to have a side and then any two other parts, and those other parts being either a side or an angle. So law of sines, and we're going to be doing law of sines and law of cosines. Law of sines, two angles in one side. That would be your, like this angle, and that. So that would be AS. Oh no, that would be yeah. No. Da, da, da. That would be angle, angle, side, because the side is outside the two angles. So angle, angle, side. Or you could have a triangle where you're given one angle, you're given the side inside the two angles. So that would be your ASA, angle, side, angle. So those are the two where you have a side and two angles, and the other one is two sides and the opposite angle. So this would be something like where you have these two sides and an angle. So it's not the angle in between the two sides. So this is side, angle. Okay. And if you have any of those situations, then you can use the law of sines, which are these ratios. So the length of the side over the ratio of the length of the side over the sine of the angle is going to be equal for all of those. So we can use that to find any of the angles we want, any of the angles or sides. Excuse me. All right, so let's see. Here we have a triangle. We have a side. So what do we? This is sort of a side and two angles, right? So angle, angle, side. Okay. And we're going to put the corresponding pieces together. So we have A. Oh, I'm not even sure why am I looking at A. Let's take the stuff that we have. We know B, so angle B. Oops. What's going on? Okay. Stop. Oh. Uh-oh. That was not good. Wow. Oh, it's all back now. Okay. Okay, so we have, what things do we have? We have the length of side B and we have angle B. We have the angle C, but we don't have is angle A. So we can use this. We'll come up here and we'll go, okay, well, we want to find out what C is. And we know sine of 102.3. And that's going to equal B, which we know the side, that's 27.4 over the sine of 28.7. So the the law of sine says that these two ratios will equal each other. So we just have to then calculate out what that is. So we'll come in here and we'll go we'll cross multiply. And then we'll go over here and we'll go sine of 102.3 times 27.4. Okay. I'm just going to do this. So we cross multiplied. Then I'm going to come in here and I'm going to isolate my C because C is what I'm trying to find. Right. So C equals the sine of 102.3 times 27.4 divided by the sine of 28.7. And yes, we're going to have to start using calculators again. Not using calculators. I'm going to get my calculator out right now. And I'm going to go sine of 102.3 times 27.4 equals, and I'm going to divide that by sine of 28.7 and equal, and that gives me 55.7. Okay, and what is this? Feet? 55.7 feet. All right, so we need to find we can find the remaining angles and sides. Okay, well, first of all, angle A. There's a triangle. We have 180, right? Minus 102.3 minus 28.7. So let's just do that really quick. 180 minus 102.3 minus 28.7, 49. Okay, so we know this is 49 degrees now. Okay, so now the only thing we have to find is the length of A. So we can do our ratios again. We'll go A over the sine of 49 degrees equals, and we'll use the same one that we used before. We'll just go B, which was 27.4 over the sine of 28.7. Okay. And again, we do our cross multiply and then solve for A. So we go the sine of 49 times, I'll do this as we go, 49 degrees times 27.4 that way. And we're going to divide that by the sine of 28.7. And A equals 43.1, rounded up. Okay. So we found C, we found A, and we found angle A. So all the different pieces. A pole tilts towards the sun at 8 degrees. And it casts a shadow, 22-foot shadow. The angle of the elevation to the tip of the shadow, the pole is 43. How tall is the pole? So you want to know what the length of A is. A equals how tall the pole is. That's what we want to find. And what are you given? We're given, well, we know that this angle here, I come in here with blue. We know that this angle B is going to be 90 plus 8 degrees. So B, angle B is 98 degrees. Right? And we know that angle A is 43, right? Because it's given. So angle C is going to be 180 minus 98 minus 43 degrees. And use my calculator. 180, 98, 43. So angle C is 39 degrees. All right. And we want to find A. We know the angle opposite A, and we know all the other angles. So let's see which two we should use. We'll go with A, which is over the sine of 43 degrees, equals, and we'll go with 22. 22, which is the length of C. We know C is sine of 39. Okay, so A equals 22 times the sine of 43 degrees, all divided by sine of 39 degrees. Sine 43 times 22. That's a different. Let's try this again. Sine of 43 times 22. And we divide that by the sine. Oops, hit the wrong button. Sine of weird. I'm getting, the key says that the answer is 33.8 feet. I'm using my calculator, and I don't have a, oh, I didn't bring a calculator. I'm using my phone. Okay. Right now I'm using my phone. I'm getting a different answer. So, let's try this again. 22 times sine, 43. Yep. And divided by sine of 39. 39. Huh. I'm getting A equals 23.84, let's say 20 feet. The key says it's 33.8, so I think, I don't know. I'm just using my phone, so maybe I'll double